Right, in this video, we're going to look at paper 1 of the exam, problem 1. Let me read it out. Guntar is at Berlin Tegel Airport watching the planes take off. He observes a plane that is at an angle of elevation 20 degrees from where he is standing at point G. So Guntar is standing right there. There's the plane in the sky, and it says the plane is at an angle of elevation of 20. That just means if you connect from the ground to the object in the sky, that angle is 20 degrees elevated from the ground, right? The plane is at a height of 350. Well, if it's a height of 350, that's not this distance, that's this vertical distance, that's straight up from the ground to the plane, 350 meters. This information is shown in the diagram. Great, there's the diagram for you, everything is visible. Now part 1a says calculate the horizontal distance, which is GH right here, of the plane from Guntar. Give your answer to the nearest meter. So we're looking for how far here, the horizontal distance. So this is called horizontal distance because this is a horizontal line. It's a line that is parallel to the horizon. Any line going side to side like that is called horizontal. So we want to know GH. First thing to notice in this problem is we have a right triangle. And when we have a right triangle, the first thought in your head should be trigonometry. So let's recap some trig ratios that we use for trigonometry. So here we have sine, cosine, tangent. Those are the three key trig ratios that we can use to solve many problems with right triangles. One way to remember what sine is, because sine it says opposite over hypotenuse, and cosine says adjacent over hypotenuse, tangent says opposite over adjacent. One way to remember this is through an abbreviation known as SOHCAHTOA. This is a good mnemonic device, helps us remember. So is S-O-H, all right? So, ka is C-A-H. Toa is T-O-A. SOHCAHTOA, all right, so SOHCAHTOA helps us remember that sine is opposite over hypotenuse. So let's take a look at that. What that means is sine of an angle. We always have an angle here. It says B. So angle B is this blue, the angle marked in blue here. So sine of that angle will be opposite side, the length of the opposite side. Opposite always means across from the angle, over hypotenuse, which hypotenuse is always the diagonal or the side across from the 90-degree angle in a right triangle. So sine of this angle is opposite over hypotenuse. Then ka, C-A-H, so SOHCAHTOA, ka, adjacent over hypotenuse. So now we go to angle B, and we take the adjacent side. The adjacent side is the side always beside the angle, and the hypotenuse is here again. So cosine of this angle will be this side over this side. And tangent, TOA, is going to be opposite over adjacent. Tangent of this angle, opposite side over adjacent side. All right, let's see how we can apply that. We have this triangle. We have this angle. Across from that angle, we have 350. So that's the opposite side. The side that we need is GH, which is this distance here along the ground. So we need the side beside the angle, which is the adjacent. So we have the opposite, we need the adjacent. So opposite and adjacent. Let's look at here again. Oh, opposite and adjacent. So we're going to use tangent. So notice I've set up tangent here. You always write it the same way. Tangent of some angle, so it's tangent of this angle, 20 degrees, equals opposite side, right here, 350, over adjacent side, which is the one we need, GH. So I've set up the trig ratio. This can't be solved though because the unknown is GH and it's in the bottom of this fraction. So we need to rearrange this to have GH over here and that we're solving for GH. So basically whenever you have a fraction and something like this, you can swap those two. GH goes there, tan 20 goes there, and we have this new equation that can be solved. When you punch this in your calculator, 350 over tangent of 20 degrees, you get 962 meters. So that's told us that this distance here is 962 meters. That answers the first question. Let's go on to 1b. In 1b, it adds a little bit more to the problem. It says the plane took off from a point T. So good thing the plane did not take off where Guntar was standing, because otherwise he would probably be run over by the plane. So the plane took off from here, T, which is 250 meters from where Guntar is standing. So Guntar is standing here, T is here, that distance is 250, it tells us. All right, using your answer from part A. So it told us directly, explicitly, to use the answer we got. Often in math studies problems, it doesn't say that, but the assumption is that you are always using what you did in the previous part to help you with the new part. So even if it didn't say that, you should always think, how am I going to use what I did before to help me with this? So anyway, it says calculate the angle ATH. So I follow the dots, ATH. So that means this angle. An angle is always defined by the middle letter here. So T tells us where the angle is. So ATH is this marked angle here. We want to find that angle. That angle is more than 20 degrees. You can see it's steeper. So we want to find that angle. So again, using what we found before, which is GH, we know GH is this entire distance, and we know this is 250 now. So how can we use that to find TH? Well, 962, I think I have it on the next page here, 962 minus 250, so the entire distance minus this little piece here will give us this leftover piece here, and that's 712, which is right here. So now we know this distance is 712, this is 350, and we have, again, a right triangle. It's this smaller right triangle right here, but it's another right triangle. So let's use trigonometry again. Let's look at what we have. Across from this angle, opposite, we still have 350. Adjacent, which means beside, we have 712. So again, we have tangent because it's opposite over adjacent. So I'm going to set up another tangent ratio. It's tangent of this angle. Last time we knew the angle, this time we don't know the angle. That's our goal. So I wrote tangent of angle ATH, which is now the unknown, is opposite 350 over adjacent 712. Okay, opposite over adjacent. So now this can be solved because our unknown is here. However, you may remember when solving for an unknown angle in trigonometry, we have to use inverse tangent. All right, anytime we need the angle is the unknown thing, we do change to inverse. On your calculator, you'll press second tan and you'll get this inverse tan. So you do inverse tan of those two divided, and the calculator will give you an answer of 26.2 degrees. All right, so that's it for that problem. Not a difficult 6 marks on that, provided you remembered your tangent ratio. All right, thank you for watching. Let me know if you need more videos like this to help you out.